Assalamualaikum and a very good day. My name is Mohamad Haikal bin Azmi. I want to present the assignment 2 vision system, recyclable material classification by using convolutional neural network or CNN. Our group member is first one Mohamad Syakir bin one Hamri, and the material number is DE200037, and me Mohamad Haikal bin Azmi CE200123, and another one Mohamad Izzul bin Suhaimi CE200081. Our introduction is effective waste segregation reduce the amount of waste sent to the landfill, saving money and improving the environment and human health. And the best way to treat waste before disposal is through image processing, that CNN system. Aluminium cans and PET bottle must also be recycled in order to protect the environment, provide and save energy. PET bottle and aluminium can recognize, and cans are typically available in a variety of color and have varying degrees recyclable significant.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Syakir bin Hamri. My number 3 is DE200037. Okay, for the assignment 2, we're gonna explain about the title of the recyclable material classification by using convolutional neural network. For the short form is CNN model. Okay, for the task 1, we're gonna use for the CNN model. We're gonna optimal model for M1, then for the 2.5 for the PET bottle and the aluminium can. There's a 3 image different. For the first is put both items side by side. The second image, PET bottle backward around 10 until 15 cm. For the third is PET will be the front and the can will be backward. So we move to the software. We use Google Colab to design and the coding to run. Okay, this is the Google Colab that I have create for the task 1. We move to the basic first for the step 1. Okay, for the step 1, we're gonna save for the file that we want, such as recycle, that our instruction have been given. We save in one file. The name is for the recycle, it is for the train and the valve. Okay, then we create for the one Google Colab file for the task 1. After that, this is our to create for the new notebook. Then we runtime for the change runtime type. After we click for the runtime, then we choose for the GPU for this hardware accelerator. Then we click save. Then after that we reconnect. We wait until it will connect with GPU. Okay, after it connect, this is for the text and this is for the code. If you want to use we want to create for the code and the text. Okay, for the first is I make a text code for the assignment 2 assignment 2 task 1 CNN model. Then for the first step is connect to the drive. This is for the first step code. We connect to the drive. I click for the run. Okay, after it have completely run, then for the second step is feed dataset directory. Okay, this is for the code. Then I click again for the run. For the step 3 is we gonna create train validation data directory. Okay, for this step, we gonna find for the data path here based on the that we save in the our Google Drive. We gonna click for the Google Drive that I have saved in the this. Then we gonna click for the such as for the recycle, and we gonna click for the copy path. After that we copy that path here. Same all this. Okay, after we copy all the path, then we gonna run for the step 3. Okay, this is the output for the step 3. Get train length for 156, PET train length for 310, and can valve length for 77, and PET valve length for 133. Okay, for the step 5 is we import TensorFlow. Then after complete, we move to the step 4, construct CNN model. In this construct CNN model, we gonna use for the code for the model TF class model sequential. Okay, then we have 3 for the layer type, output shape and parameter. The output, and this is for the output for the total parameter, trainable parameter and non-trainable parameter. Okay, then after complete, we move to the step 5, pre-process the input data. After we click for the pre-process input data, the output will come out for the found 466 image belong to 2 classes, same to 10 2 classes, data batch shape 10 150 and 3 label batch shape for the 10. Okay, for the step 6 is to start training process. This is for the long way to wait that I have set for the ePush for the 10 cycle of ePush. Then we move to the step 7, plot the outcome. This is for the code to we plot the training and validation accuracy, and for the training loss and validation loss. Then we try run it again. Then after we run it, then we get for the training and validation accuracy and training loss and validation loss. Okay, we can compare. The training validation accuracy is more greater and bigger than for the training loss and validation loss. For the last step, we're gonna compare for the three image that we have take for the pet and the can. Okay, this is for the file that we're gonna import from the file. Then we're gonna move to the first image that pet and can stay same distance from the camera screen. Okay, this is the code. I run the code. Then we can compare for the output. The image is compare. It will become 100% that it will have been successful. Okay, this is for the image for the side by side, both pet and can. Okay, for the second image, can stay and pet move further backward. It also become 100 successful. And this is the display image. After that, for the last image is pet stay and cat move further backward. It also have 100% successful. Okay, for the last is can front. Okay, that's all for me for the task 1, the CNN model.
I think the task 2 for assignment for step 1 is, of course, we need to connect this using this coding Google Colab with our Google Drive. So now after the step 1, we run the code, it will mount the content to my Google Drive. Step 2, fit dataset directory. So as you can see, this is the path content G drive, my drive, vision system. The vision system is a folder that I've created in my Google Drive to be connected to this Google Colab function that we need to use for create a training validation data directory. So of course, using the folder that I created in my Google Drive, we put the folder path into our coding, and after we run after I made the code and run the code, we found the result is the can train length is 156, the pet train length is 310, can validation length is 77, and pet validation length is 133. Construct pre-trained model with VGG16, run our code. We found that there's, as you see, there's so many blocks from using the input from block 1 until block 5. They pre-process the input data coding. You find that the image will classify into a few classes. So we found that there are 466 images belonging to 2 classes, 210 images belonging to 2 classes. The data batch shape is 10, 150, 150 and 3, and lastly the label pet shape is 10. Now it's the step 6, start training process. So in our group, we decided to do 10 epoch. So you can see there are 10 from 1, epoch 1 out of 10 until epoch 10 out of 10. And next is the step 7, which is plot the outcome. So we do this so that we can create a graph to know that our result. As you can see here is the training and validation accuracy. The dotted is the training accuracy. We want the line represent the validation accuracy. And next is the training loss and validation loss. As you can see, the both the training and validation are quite similar to each other. And now step 8, test with 3 images. So using the file that we import to Google Colab, we try to test the few images. So the first one, the pet and can stay same distance from the camera screen. As you can see, this image is 100% can and 100% pet. So yes, I successfully identified the image, and they are both in the same distance. And the next one is the can stay and the pet move further backward. By pet, I mean the bottom. And it successfully do as it, and the coding successfully do as we program. And lastly, the pet stay and can move further backward. So the bottom stay there, and they can move further.
Assignment 2, task 2. The first step, we write the code, we run the step 1. For the step 2, this we are create from the folder that right click and copy path and paste at here. Run. The step 3 also. So we run. Coding below as the same thing to do. Write the folder. And for the train, right click at the train and paste here. And the train can, this can paste here, and we get the can train length 156, pad train length 310, cat valve length 77, pad valve length 133, and you can get pad length 133. That's construct 310 model with denset. Denset is a pre-10 model. The layer type that show input or input layer, and the output shape 150, 103 or anything, and the param hashtag, and connected to. For the next step, the total params that we get is 15427,137, and trainable params 8389, 633, and non-trainable params 7037, 504. Pre-process the input data. Found the 466 image belonging to two classes, and found the 210 image belonging to two classes, and the database shape 10, 150, 150 and 3, and the label bench shape 10. The next step, start training process. After the step 6, start training process already done, it show the only 10 push like this. Next step, we run the coding, and they show the graph, the training and validation accuracy like this, and another one is training loss and validation loss like this. Test with 3 image for the step 8, and for the coding, this is also from the folder that we show before, the image, and this pad and can side by side, and this image, the pad front, can back the pad move, and the can stay. And for the another coding is pad stay and the can move further backward. So we show the image. You see the can in front and the pad at the backward.
For the conclusion of our group, student modules from the network to investigate the recyclable material classification of polyethylene, terephthalate, bottles, and aluminium can. The convolution neural networks such as CNN, BDG, and DeskNet are frequently employed for image classification. We found that the BDG model is more complex than the DeskNet model. We also, of course, discovered the use of this technology that can be used in the recycling center, and maybe even more in wider spectrum. So that's all from our group. Thank you.